Okay, hello everybody. This one is about lines and planes. So give examples and pictures in your explanation. And so your explanation should be in your own words with your own examples and pictures. And I'm giving you some freedom in terms of how you're going to answer this. For part A, explain how this equation is the equation of lines in the plane R2 and also of planes inside of R3 space. And so you'll note that there's a 0 here, and so you'll have to explain what that means and give some examples of this. And then part B, if we have something like this, you should give explicit examples and draw some pictures, and specifically explain what happens for C, a positive real number, or a negative real number. Okay, so for part A, explain how n dot x equals 0 gives equations of lines and planes. So first, lines. So first I tell that n is in R2. So just what is n? Well, it's in R2, and it's a normal vector. So fixing a normal vector n, the set of all the points x that satisfy n dot x equals 0, which I show exactly what that means, forms a line containing the origin. So that line contains the origin because this right-hand side is 0. For example, if n is 2, 1, it gives this explicit equation, 2x1 plus x2 equals 0, which becomes this picture. So I drew n, and I drew the line, and then I labeled it every vector x, like this purple vector, on this line is orthogonal or normal to n. That's why we called it n, and that's why we call it a normal vector. For n in R3, this gives a plane of all the x's, which are the variables, whose dot product with n is 0. And so this is what that means in space. And space is three-dimensional, and we put one equation on it, which gives us a two-dimensional plane. Sort of this one equation drops the dimension down from 3 to 2. And the linearness of this equation means that our two-dimensional object will be flat rather than curvy. For example, if n is this vector, then I get this explicit equation in the x's. It defines a plane of all the x's that are normal to that vector. And I drew a picture of this, and I drew one of the x's, and it's right at its right angle, and said, this is the plane of all the x's. In this case, it contains the x3 axis, which is this axis, just because of this particular n that I chose. If you have some vector on the x3 axis, well, then it looks like 0, 0, something. And no matter what, with this n, you're going to get a dot product of 0. So that's how we can see it contains the x3 axis. You don't have to talk about this specific example, but this was my way of talking about an example in detail. Okay, so that explains how n dot x equals 0 gives equations of lines and planes. How does n dot x equals c change the picture? So now c could be either positive or negative. So the equation n dot x equals c shifts the line or the plane off the origin. So if c is positive, it shifts in the direction of n, and if c is negative, it shifts the other way. Okay, and then I draw a picture, so I can take n equals 2, 1, and let's say n dot x equals 5, and that's this purple line here. All the vectors x on that purple line have dot product 5 with n. So n dot x is 5. That's what I've said in this picture. Of course, I didn't label the picture precisely, but that's okay. And now this picture has a second piece, namely this other pink line. It has the same normal vector, so the tilt, the slope of the line is the same, namely determined by this normal vector, giving the tilt. And then all these pink arrows are the x's that have n dot x equals -7, is what I said. And the point is that it shifted the other way. Shifts the line off the origin in one of the two directions. Okay, and that's it. That explained how putting a right-hand side changes the picture.